So yesterday, just to switch off my brain after a long day of work, I was trying to find a pocket of positivity on the internet, which is not easy. Because everything is about Muslim invasions, feminists crashing society, declining IQs. Yeah, even more. They're sinking even lower. And, it's always a party when I find some new essay by Bostrom or someone like that. Not that there are very many people like that at all. But yesterday I found an essay. I don't even know if it can be called an essay. It's 96 pages by MIRI, the Machine Intelligence Research Institute. The title of this, what do you want to call it, paper, written by Yudkowsky, is Intelligence Explosion Microeconomics. Now, all of these bitches that are coming on my videos and saying, hey, some women are smart. Fuck off, bitches. Fuck off. Go fuck yourself. Show me a woman that wants to talk about microeconomics of an intelligence explosion, huh? And I'll show you my dick on a platter. Idiots. Anyway, part of the reason I want to read this is because I want to diversify my channel. I don't always want to talk about issues that are of interest to the lowest possible common denominator, that is, talking about people. Fuck that. There are some important issues, important changes that may or may not happen, and that game is being played right now. So the stuff that I actually care about, I don't care what women want, I don't care if women are smart or not, I don't care of any of that bullshit. All I care is issues of this type. I don't have time to go over the whole thing. As I said, it's 96 pages. But a particularly interesting chapter was where Yudkowsky tries to defend the model of a hard takeoff. Takeoff refers to the takeoff of intelligence, when everything becomes intelligent. And a hard takeoff implies that, well, it refers to the possibility that this takeoff might happen very, very quickly. And of course, that's tied into recursive self-improvement. So the key issue here is, because a lot of people have objections, or they say, no, the singularity can't happen, or no, you cannot have increasing benefit out of more and more intelligence unless you also add the ability to quickly sense and manipulate your environment. A bunch of objections, right? So here he tries to defend his model of a hard takeoff, which is what his institute, the Machine Intelligence Research Institute, gets funded to address, because if there's not going to be a hard takeoff, then he's not doing anything useful. Intelligence is just going to be absorbed by society like water in a sponge, and there's not going to be like one single aggregator of intelligence or any AI that becomes superhuman and just leaves it behind by billions of years of advancement. So it's important for him to justify this model. It's what he's getting paid based on. So he's going to try his best. So this is I think this guy is beyond human in intelligence. He's not neurotypical. He's something else. So you'll see how he writes. This also ties into the whole, what is intelligence? And all of the morons that are commenting on my videos. Intelligence is something else. Intelligence isn't even what I talk about, because I'm just trying to repel the idiots with the pitchforks. Real intelligence is the following, what we're going to read right now. That is, you find yourself on a planet, you look around, draw some conclusions, figure out what you're supposed to do, and then go ahead and do it, and make predictions as far as possible into the future. addressing the vast chaos of, just the complexity of the world. That this is what an intelligent agent does. It creates an optimal outcome in a complex environment. So let's begin. This is page 28, chapter 3, Some Defenses of a Model of a Hard Takeoff. And so I'm going to skim through this. I can't possibly read it all. So there will be pauses while I find what I want to talk about. Now, the way he writes is very compressed, so many of the sentences will require explanations. So he says, for example, some sort of AI project run by a hedge fund, academia, Google, or a government advances to a sufficiently developed level that it starts a string of self-improvements that is sustained and does not level off. Why is he talking about leveling off? Because that's one of the main items of contention. Is the singularity is based on the idea of exponential increase in intelligence with self-improvement. So you could hypothesize that intelligence, once it reaches a certain threshold and is able to affect itself and rewrite itself, necessarily goes off on an exponential self-improvement trajectory. Or you could say that it levels off, that slowly adding more intelligence does not allow you to expand intelligence much faster. And so that's a very different scenario. Like literally the fate of the fucking world and the universe depends on this one thing. Does this curve level off or not? I can't stress enough how important this is. It's as if you were one of the people, Mayans or whatever, in the Americas, and you see these boats at the horizon. And if you were to ask a question, do these people carry pathogens or not? The future of everything depends on this one bit of information. So Yudkowsky argues that it doesn't level off. He hasn't begun to argue it yet. He will do it shortly. He's just describing this cascade of self-improvements might start due to a basic breakthrough by the researchers, which enables the AI to understand and redesign more of its own cognitive algorithms, or a soup of self-modifying systems governed by a fitness evaluator, after undergoing some smaller cascades of self-improvements, might finally begin a cascade which does not level off. So here he's taking into account the possibility of using some variation of genetic algorithms with some fitness evaluator. The reason he's talking about this is that adversarial networks and automatic evaluation of the fitness of certain algorithms is a hot topic in AI, and it's related to how they were able to pull off all of the recent stunts like winning at the game of Go and so on. Or somebody with money might throw an unprecedented amount of computing power at AI algorithms which don't entirely fail to scale. Why is he talking about failing to scale? Because most of the stuff that... He's a big believer in algorithms over speed. Not to say that you don't need speed, especially if you're running on a serial computer, trying to emulate parallel computation. But he's a big believer that algorithms are more important. In fact, somewhere else in this essay, he says it's better to have new algorithms running on old hardware than old algorithms running on new hardware. And so normally algorithms, they do fail to scale. But it is possible that some algorithms, if you just increase computing power, they might not entirely fail to scale. Okay, so if one of these things that he just described happens, then he says, once this AI started on a sustained path of intelligence explosion, there would follow some period of time while the AI was actively self-improving and perhaps obtaining additional resources, but hadn't yet reached a cognitive level worthy of being called superintelligence. This time period might be months or years or days or seconds. I am greatly uncertain of what signs of competence the AI might give over this time, or how its builders or other parties might react to this. But for purposes of intelligence explosion microeconomics, we should temporarily factor out these questions and assume that the AI's growth is not being deliberately impeded by any particular agency. There's a lot to unpack there. For example, why is he talking about microeconomics? So the whole point of this paper is to try to chart some space at the intersection of microeconomics and the intelligence explosion. Microeconomics ought to be related to, well, first of all, economics, but on a micro level, because you're looking at various different, say you postulate the existence of a very large set of different actors. And the serious economics is when you take into account how what you change will change the incentives, which then changes the system. It's one of the things that, for example, Molyneux talks about in his rebuttal of the universal basic income, that the idea that you're going to change the incentives, no, the idea that you're going to have a government program that fixes some problem and not take a look at how that's actually going to change incentives, which change people's decisions, which then change the system itself, is absurd. So in the way that microeconomics is intended here, they're really looking at the development of the system being the planet, with all, academia, corporations, governments. Once you start getting this exponential increase in intelligence, or even if it's not exponential, it doesn't matter, but this upcoming great increase in intelligence with AI, how everybody's going to respond and how that's going to change incentives and what exactly is going to happen. Because the fundamental question is, what the fuck is going to happen? Everybody wants to know what's going to happen. If you don't know what's going to happen, again, you're like looking at those boats in the distance and not knowing, do they carry pathogens? Because if they carry pathogens, you're about to die. There are some answers to this question of intelligence explosion microeconomics that might tell you that you're going to die, like soon, like in the next 30 years. And some other aspects that might even tell you, yeah, you're going to die, but if you do this, you might not die. And when he refers to what signs of competence the AI might give over this time, the reason he's talking about signs of competence is because our stance right now is that we're creating something that is omnipotent and potentially dangerous. So if we knew some signs, if somebody that's already gone through tens of singularities before, like an alien civilization, came to us and said, look, when this thing passes the Turing test, that is the sign that you're about to have an intelligence explosion. Or maybe it's not that. Maybe it's when it figures out the protein folding problem. Okay, so that's the meaning of this sentence. At some point, the AI would reach the point where it could solve the protein structure prediction problem and build nanotechnology, or figure out how to control atomic force microscopes to create new tooltips that could be used to build small nanostructures, which could build more nanostructures, or perhaps follow some smarter and faster route to rapid infrastructure. So all it's saying here is that if a machine becomes intelligent enough, just by being intelligent, it gives you domain over the physical world. It gives you godlike powers over the physical world. And the most likely ways that you're going to be able to do this is either you fold the protein structure prediction problem, where you can create a sequence of nucleotides that you get some lab to build for you. You can do it by mail. And create a protein that is able to position atoms where you want it to position, or an ensemble of different proteins, right? Proteins in the end are wet nanotechnology. Or you could go through the other channel of using atomic force microscopes as tooltips to create new tips that allows you, anyway, you get to the point where you have control over matter, godlike control over matter, full molecular nanotechnology. And he understates it like an AI that goes past this point can be considered to have reached a threshold of great material capability. This is like saying, he's a man of great wealth, and he's got $100 billion. It's not great wealth. He's fucking loaded. like some people say, he's got more money than God. But he's saying great material capability, meaning it does whatever the fuck it wants. You have no chance. From this would probably follow cognitive superintelligence, if not already present. That's an interesting possibility that he might get there while still not being superintelligence. Maybe the ability to create nanotech is just one step above human. It doesn't require a very high order genius. It just requires a little bit above human. You could get nanotech, but then you could use nanotech to really go very, very far cognitively. The further growth trajectory beyond molecular nanotechnology seems mostly irrelevant to present-day policy. An AI with molecular nanotech would have sufficient technological advantage, sufficient independence, and sufficient cognitive speed relative to humans that what happened afterward would depend primarily on the AI's preferences. That's it. If you get there, godlike intelligence, godlike powers, anything that happens in the universe after that is because the thing wants it to happen. We can try to affect those preferences by wise choice of AI design. So once it becomes that powerful, there's nothing else you can do. But if you can catch it soon enough, before it becomes that, you might be able to affect what it wants in the future. Now, he's not going to talk about the issue of how to keep this thing friendly because he discusses it everywhere else. But what he's trying to do again in this chapter is to defend the idea that this hard takeoff is indeed realistic. So the reason economics gets put into the picture here is that if you take economics, right, the basic idea of economics, and I would say there are many basic ideas, but like one of the crucial ideas is that if you run a small lemonade stand and you make some money, you can reinvest that money to get like now a lemonade shop. And then if you make money with that, you can then have a chain of shops. And so there's this idea of compound, it's not even compound interest, but it's the effect. Sorry, I just got an email. I need to check this. All right, no problem. So they draw a comparison because that's really what this is. It's the idea. If you're saying that there's going to be a hard takeoff, you're also saying that there's such a thing as cognitive reinvestment. It's like reinvesting money into your business. If you become smart enough, you reinvest that intelligence on becoming smarter and so on and so forth. And as you know, the law of reinvesting your finances can yield people like Bill Gates that have billions and can yield people that are completely poor. And so if this can be ported to the domain of cognitive abilities, then of course you can have people that stay human, like we've been doing. And then you can have beings that become unbelievably intelligent, that have an intelligence what Bill Gates has in money. So you can then say they're smarter than God. They're smarter than God. Okay, anyway, it supposes that these are the assumptions that you need to. No, they're the general beliefs that are implied by the hard takeoff. So you have to believe these things in order to believe in a hard takeoff. So first of all, an AI can get major gains rather than minor gains by doing better computer science than its human inventors. So what this means is that we're there hacking away at the problem, but we're stupid, and so we're making very small progress. But if an AI was smarter than us and it started tackling the problem itself, then it will go really, really fast. So that's an assumption that you don't get diminishing returns, okay? And that's an important part of the whole landscape, because there are some things where it doesn't matter how many resources you throw at the problem, you can't go faster. And he's going to give some examples of this. It's quite interesting. And then there are some problems where if you just multiply the resources that you have, you can go faster. Think of building a wall. The more people you have working on it, the faster you go. Whereas, I don't know, scientific progress, sometimes you need to wait for one thing to be invented before you can invent the next. And so even if you had 1 million people working on the same problem instead of 1,000, perhaps they wouldn't go that much faster, and the whole timeline of the progress would also not be accelerated significantly. He's going to talk about these and more interesting examples later, I think, if it is in this chapter. This thing was very long. More generally, it's being supposed that an AI can achieve large gains through better use of computing power it already has, or using only processing power it can rent or otherwise obtain on short timescales. In particular, without setting up new chip factories or doing anything else which would involve a long unavoidable delay. So what's it saying here? It's saying that once you get this thing started, it's going to be able to find enough computing power to expand its capabilities without having some sort of bottleneck in the real world. So if you get an AI that says, oh, I know how to get to 1 million times smarter than I am, but we need to scale transistors down to, I don't know, many less nanometers than they are right now. And so then you have to build the plants and you have to staff them, and it's going to take a long time. So a hard takeoff would imply that this is not necessary. If you believe in a hard takeoff, that this is not necessary because you can just use the computing power you already have, or send a virus through the internet and use that as computation, or send a virus to Deep Blue and all the major supercomputers in the world, or just rent the time. For example, you can find some kind of way. You can master some quantum way of cracking security and then crack Bitcoin and steal all the Bitcoins in the world and then use that to rent computing power, right? I move on. An AI can continue reinvesting these gains until it has a huge cognitive problem-solving advantage over humans, which is what I was stating in the beginning, the idea that you can reinvest intelligence the same way that you reinvest business profits. This cognitive superintelligence can echo back to tremendous real-world capabilities by solving the protein folding problem or doing something else even more clever. See in section 311, which is really interesting. I hope we can get to that. When he starts talking about unknown unknowns and how something that's smarter than you is not going to use the methods that you thought it was going to use. It's just going to do something that's magic instead. So why believe that? And here's where I have to start taking small pauses because I have to make sure I read the right stuff. Otherwise, it's going to take hours just to read this one chapter. So it starts out by saying that the evolutionary history of hominid intelligence doesn't show any signs of diminishing returns. There's no sign that evolution took 10 times as long to produce each successive marginal improvement of hominid brains. This is hard to quantify, but the anthropological record doesn't look like it should look if there were significant diminishing returns. And then he covers this in 3.6 in detail. Now, this is what intelligence is, okay? This is what it fucking is. I come to your planet, you're a bunch of fucking morons, and I ask you, so, what's the exam question? Tell me how likely it is that you're going to get a hard takeoff of artificial intelligence. Like, I don't fucking know. We've never had one. Will computers be able to improve faster and faster, or will they reach some kind of bottleneck, or will they taper off? But what intelligence does is find the appropriate reference class for something that's similar and try to draw a conclusion. In this case, what people do is look at the evolutionary history of humans and say, is it the case that each time we got an intelligence upgrade, it took longer and longer for nature to come up with the next? Because if that was the case, then it would be true that the problem gets harder and harder the more you tweak it. But instead, looking at the record, anthropological record, doesn't show any such slowdown. And that doesn't mean much, but it means a little bit. It means that certainly, by looking at that, we cannot say that we're near some kind of bottleneck, that nature has already done everything that could be done, and that we only have marginal improvements to make in the future. Unbelievable usage of intelligence, which does a kind of magic, because you get to be able to predict something that you wouldn't know otherwise. And, the bioremediation strategy of Aubrey de Grey, where he used the fact that cadavers do not accumulate and form giant piles in graveyards, indicates that there's an enzyme possessed by some bacterium out there that can degrade the stuff that our body's not able to degrade. And so they went out and found the bacteria and found the enzymes, reverse engineer them, put them in the cell, made sure that they're transported into the lysosome. That's another type of intuition that requires high intelligence. So that's what intelligence does. Something that seems impossible to know, impossible to solve. We actually have a way. It's almost like you can know something without knowing it. That's what it looks like. We have a fairly good mathematical grasp on the process of evolution, and we can well approximate some of the optimization pressures involved. We can say with authority that in a number of important senses, evolution is extremely inefficient. So now it's characterizing what we're comparing all of this to. Evolution keeps going steady in intelligence increase, but it's very inefficient. So if we're not near a bottleneck and we're not extremely inefficient like evolution, we should be able to make quick gains fast. Evolution was able to get significant cognitive returns, see how it's using the language of finance, on-point mutations, random recombination, and non-foresightful hill climbing of genetically encoded brain architectures. So the poor tools that are available to evolution, such as mutations, recombination, and just random fucking around, actually gave significant cognitive returns. And another very intelligent thing he says, furthermore, the character of evolution as an optimization process was essentially constant over the course of mammalian evolution. There were no truly fundamental innovations, like the evolutionary invention of sex and sexual recombination over the relevant time span. So it's saying that all of this increased intelligence was not even requiring paradigm shifts in the algorithm that produced the intelligence. So we're looking at a strictly linear process that keeps on piling up results, and it's not even slowing down. Of course, the comparison there implicit is, well, with AI, we are going to have fundamental innovations, and all the time too, and they will be getting faster and faster. So evolution is no match for design by intelligent machines. So if a steady pressure from natural selection realized significant fitness returns from optimizing the intelligence of hominids, then researchers getting smarter at optimizing themselves ought to go foom. Foom is the sound that you're going to hear as the world is turned into computronium, the day that the singularity happens. It's often referred to as foom. All right, now I need to figure out where to jump next. So he talks about bottlenecks, because the fundamental issue at hand here is there going to be a bottleneck that stops your intelligence explosion or not. So what he says, some amount of my confidence in AI go foom scenarios also comes from cognitive science. For example, the study of heuristics and biases. If you don't know, this guy has a website called Less Wrong, which is an amazing source of tips for thinking rationally and analysis of many kinds of human cognitive biases. So his studies of heuristics and biases suggest that humans are very far short of optimal design. Most humans cannot multiply 2 3-digit numbers in their heads. And what that tells you is that at least along some dimensions, we're very, very poorly designed. On a higher level of abstraction, this is saying that there exists great visible headroom for improvement over the human level of intelligence. It's extraordinary that humans managed to play chess using visual recognition systems, which evolved to distinguish tigers on the savannah. Amazing that we can use brains which evolved to make bows and arrows to program computers. And downright incredible that we can invent new computer science and new cognitive algorithms using brains mostly adapted to modeling and outwitting other humans. But by the standards of computer-based minds that can redesign themselves as required, and run error-free algorithms with a billion steps of serial depth, we probably aren't thinking very efficiently. So what's he talking about here? Redesign themselves. We can study, we can try to fix our biases, but we can't rearrange our brain parts and redesign our mind. Computers will be able to, and also we cannot run error-free algorithms with a billion steps of serial depth. So the serial depth is simply the number of serial sequential tasks that you do before you get some kind of result. And humans vary a lot in this. Some people, they want to know how to make money today, but some other people think, okay, well, I'm going to study which school is the best so that then I can try to study how to get into that school, so that then I can go to the best school, so that then I can get the best job, so that then I can meet the best people, so that then I can be rich, right? So the serial depth. Some humans are able to tolerate 12 steps, some more, some less, but a computer can handle billions of steps. So we have that huge handicap with respect to machines. These are reasons why we should suspect the cognitive algorithms can be improved beyond the human level, that we're nowhere near optimal. So then, this is the introduction to chapter 3, but then he goes into each one of the points that he made. First, examining the fossil record. That is what he draws his inference about returns on brain size from. And then that's 3.1. Then 3.2, how to divide credit for the human-chimpanzee performance gap between humans are individually smarter than chimpanzees, and the hominid transition involved a one-time qualitative gain from being able to accumulate knowledge. So, I don't even know what this means. Let me read further. Actually, I don't know if I read this. I don't know what it means, but it's basically analyzing the performance gap between monkeys and humans and analyzing that. Each one of these sections has some really brilliant intuitions that are by no means evident. I don't know over the course of how many years these things came to the surface, probably through answering objections and I'm still reading sections. Section 3.4, for example, has to do with human populations and how they scale in problem-solving power, which gives reason to believe that we scale more inefficiently than machine intelligence would. This is important because it's one of the ways that people try to rebut the hard takeoff hypothesis. They try to say that groups of humans are also self-improving, competing cohorts of intelligence, and they compete in how they put together the resources and so on and so forth, but he analyzes that, and I think it's intuitively makes sense that if you have a person that's like 10 times smarter than everybody else, there's a lot of stuff that he can do that no matter how you put together. I mean, no matter how many monkeys are typing, they're not going to come out with a book that makes sense. Then 3.9 is very interesting about whether to expect a local FOOM, that is a one project taking off, or a global FOOM, where the whole economy and the whole ensemble of humans, cyborgs, and AIs, everything goes FOOM. That's really where we're talking about microeconomics in the real sense of the word. And then the enhanced importance of unknown unknowns. So I want to read 3.11 because it's very entertaining, and the rest is just very, very dense, very, very thick, and it's going to get really long. So let's just go to 3.11. Returns on unknown unknowns. After making the case that we have this reason and that other reason to suspect that we will get a hard takeoff, and looking at how we as humans are inefficient, and how evolution didn't seem to slow down in recent evolutionary time, even though it's quite primitive and so on and so forth. Now he's talking about, listen, actually everything I said until now is complete bullshit, because if you get something that's smarter than you, it's not just going to do what you think it's going to do. It's going to shock you in its abilities. So let's just read it. Molecular nanotechnology is a fairly recent concept, and 19th century humans didn't see it coming. Already this sentence, it's like amazing. Just imagine if you could have built a super intelligence in the 19th century when there was no word for molecular nanotechnology, but clearly if you make an AI, it's going to get to molecular nanotechnology the next day, if it's self-improving or in short order. So imagine people in the 19th century that create this thinking machine, and the next day it's got complete power over matter. They would never have suspected that. They thought they were building a thinking box, but they built God. And now it can do whatever it wants. So that's a small introduction. There is an important but dangerous analogy which says that the 21st century can do magic relative to the 11th century, and yet 1,000 years isn't very much time. That to chimpanzees, humans are just plain incomprehensible. Yet our brain designs aren't even all that different, and that we should therefore assign significant probability that returns on increased speed, like serial time, speed of the brain, causal depth, like as I was talking before, how many sequences, how many sequential steps you can plan and execute. More of the distance which separates the 21st and 11th century of human history. And now I'm sorry because I put the brackets inside the brackets, so now you're not going to be able to understand the rest of the sentence. Let me just read it again without interjecting. There is an important but dangerous analogy which says that the 21st century can do magic relative to the 11th century. Okay? We should therefore assign significant probability that returns on increased speed or improved brain algorithms will end up delivering damn near anything in terms of capability. So read it again. There is an important analogy. It is dangerous, but it's an important analogy, which is that because of the reasons that it states, for example, that we're very close to chimps in our brain architecture, that if you just get a little bit smarter, you can expect absolutely anything out of that. This may even include capabilities that violate what we currently believe to be the laws of physics. Completely conceivable. You make this super smart thing, tomorrow it's going faster than light. Just because our standard model of physics might be wrong somewhere, we cannot conclude that any particular error is probable, and new discoveries need not deliver positive news. There might be negative news as well, some other restriction like the speed of light limit, but irrational agency will selectively seek out useful physical possibilities that we didn't know about. So any laws that we didn't know about, it's going to exploit those. So an important caveat is that if faster than light travel is possible, so you imagine you make this thing and you're quite convinced that if there's a way to go faster than light, it's going to figure it out and harness it. Well, then the Fermi paradox becomes a little bit harder to tackle because, again, where are they? This gives us some reason to believe that nobody will ever discover any form of magic that enables faster than light travels, unless it requires a faster than light receiver that must itself travel at slower than light speeds. This is what intelligence is. Because he's encompassing also the possibility in which, yeah, you can go faster than light, but first you got to take some kind of receiver and put it there, and you can't go there faster than light. Just like a time machine. To communicate something back in time, there are now theories, experiments that say, yeah, you might be able to communicate something back in time, but not before the invention of the machine itself, which has to do the receiving. So drew a parallel with that, I suppose. And in the same way, if time travel was possible, we should be seeing a lot of time travelers. So there's still ways in which you can put an upper bound to the capabilities that you expect the AI to get. is another one of those things, the the self-sampling assumption that Bostrom came up. Should put it up there with the bioremediation hypothesis of Aubrey de Grey and what Yudkowsky is doing right now here, trying to predict whether the takeoff is going to be hard or not so hard. It's just another thing that it seems like you can't know. You have zero information, and yet Bostrom, just because he's smarter than you, figures out a way, hey, actually, since we should expect ourselves to be average observers, just by the fact that we are here and we see this thing around us, we can know something about the universe that we otherwise wouldn't know. Extremely interesting self-sampling assumption. There's SSI and SAI. I think there's a whole. That's actually his main contribution, other than waving his arms around about superintelligence, is to talk about this area of philosophy, about how to rationally think about your position as an observer. Anyway, from my perspective, the possibility of returns on unknown unknowns, returns on magic, or returns on the superintelligence being smarter than I am and thinking of possibilities I just didn't see coming, mainly tells me that 1, intelligence explosions might go boom faster than I expect. 2, trying to bound the real world capability of an agency smarter than you are is unreliable in a fundamental sense. And 3, we probably only get one chance to build something smarter than us that is not uncaring with respect to the properties of the future we care about. I think this is the main point here. That he believes that even though you can try to extrapolate knowing what you know, something that's smarter than you is going to have access to mechanisms of the universe that you don't know yet, because you are not smart enough to know. Either you haven't gotten there yet, or maybe you can't even understand them. What if it figures out subjective consciousness? Take the quantum suicide, for example. You make the AI and it keeps shutting itself down. And you think, oh, well, it didn't work. No, it did work. Just it's using something that just 50 years ago you would have no idea about. You would have no idea about quantum mechanics and about the quantum suicide, but it figured it out. So it's getting whatever the fuck it wants out of the universe with the quantum suicide, and you're stuck there like a monkey looking at the box doing nothing, thinking that you failed, right? So, and intelligence explosions might go boom faster than I expect. So he expects it to go, of course, very, very quickly. But what if the AI finds out something, like I said, quantum suicide or time loops, finds a way to send a bit back in time. Now it's got unlimited computational power, meaning that it can go boom in a Planck time length. And trying to bound the real world capability of an agency smarter than you are is unreliable in a fundamental sense. So to say something that's smarter than me is probably going to be able to do this, this, and that other thing, but not that and the other thing. That's stupid in a fundamental sense. You can't know. You have to treat it as like an event horizon. When something is smarter than you are, there's no telling what it's going to be able to do. And it makes sense. This is true across the animal kingdom and also across IQ levels in people. We probably only get one chance to build something smarter than us. Okay, so this is the main point. If all of this is true, it means that we should expect that this thing is going to be God the first time around, and not that it's going to taper off and we have to try it 2 or 3 times and things are going to go slow and allow you time to think. No, you have one chance to imbue this thing with some sort of level of care for not using up your atoms for something else. If you fail the first time, most likely you're fucked. I am not properly sure what sort of procedures ought to be put in place for arguing about the possibility of returns on unknown unknowns, such that in a world where there were in fact no significant returns on unknown unknowns, you would be able to figure out with high probability there were no unknown unknown returns and plan accordingly. In other words, there's no way to know for sure that there are no such unknown unknowns that you have missed. That is, that magic cannot happen the moment you turn the thing on. He's not sure what procedure could be put in place. The way he structures the sentence itself is highly intelligent. This is not the way that people usually use language. He's using it like computer code. I'm not properly sure what sort of procedure ought to be put in place for arguing about the possibility of X, such that in a world where there were in fact no returns on X, you'll be able to figure out with high probability there were no returns on X and plan accordingly. Yeah, it's not the simplest way to put it, but I do think that proposals which rely on bounding smarter than human capacities might reflect a lack of proper appreciation and respect for the notion of something that is really, actually smarter than you. In other words, he thinks that most people that naively think about these problems, yeah, they're saying, oh, it's smarter than human, but they don't really believe it. They think, oh, okay, well, whatever, it's faster, it's going to do some tricks. No, it's actually really smarter than you. And he knows, because he's somebody who's smarter than anybody else. And he can see very easily, what's he doing? He's trying to save the world and trying to make it so that the God that we're about to create, which nobody even knows we're about to create it, certainly not when he started talking about it 20 years ago, trying to make sure that that's a friendly God, whereas everybody else is just chit chat and Tinder. Okay, so he knows what it means to be more intelligent and the whole world that opens up. So he knows that if something that is more intelligent than him by a factor of 1 billion, whereas he probably correctly sees himself as, 10 times smarter than the average individual, if you can even compare it like that in a scale. Anyway, he's a tiny bit smarter than the average human, but this thing we're building is a colossus. It's going to be like a fucking planet. He knows it's stupid to try to say it's not going to be able to do this, it's not going to be able to do that. You have to assume, for your own survival, your own safety, that this thing can do anything. The moment you start it, it's God. No limits. Faster than light travel? Perhaps. Back in time? Perhaps. Things you don't even know yet. Influencing multiple universes. Maybe there's something more important than the universe that we're contained inside and we can't see it. All right, so that's the same thing as saying, hey, if you are an indigenous population and there's some other population that's coming at you with boats, it's safe to assume that they do carry pathogens. You don't just say, oh, whatever, they're probably not carrying any pathogens, because you end up dead. So it's saying it's not coincidence that I picked my policy proposal so as not to be highly sensitive to that estimate. In other words, what he recommends does not require figuring out just what something that's smarter than you can do or cannot do. All right, so this is a snapshot, slice of mental activity of somebody that is intelligent. So intelligence means, first of all, he knows what the fuck is going on. This is not somebody who thinks, oh, there's God. It's not somebody who thinks, oh, has any superstitious or irrational beliefs. That's the first thing. He can see things and categorize them appropriately. So, he's not Christian, he's not Muslim, he's not anything like that. Second, out of this information, he's able to know what's good for him. We're made of matter, so if we can extend our intelligence and get control over matter, we live forever. We figure out what we ought to do and then do it. So that's very high level of utility. And if we don't do it or we get it wrong, then we get 0. That's very low level of utility. So he knows what's good for him. And then third, he's trying to narrow the range of possible futures to what's good for him and for us. Okay, so have vision. You know what the world is without biases. Second, you figure out what's good for you and not for your genes, clearly. And third, you work hard on making the future a positive one. And as you go about doing it, you're also effective because you're intelligent. That's intelligence. All these fucking people saying, women are smart. You're just playing a psychosocial ancestral game. You don't know what the universe is like. You have no idea about superintelligence. You have no idea about your cognitive biases. You don't even have an IQ score. You're not playing the game of intelligence. You know, if everybody's taking a test and you're out playing baseball, what's your score on the test? You don't have one. You flunked the class, but you don't get a grade. You don't deserve one. You didn't even try. So your IQ is either 0 or X. There was another important thing in this essay. Which now I don't think I can remember. Yeah, I don't think I can just scroll and find it. It was another very important point. Oh, yes. So, I don't know if it was Bostrom or Omohundro who published a paper reminding people that even though you can design an AI in any way that you want, there's a kind of convergence in their drives and the things that they want. So it doesn't matter what you're optimizing for, having more resources makes you better at optimizing for that thing. And that's an ominous bit of information, because it means that no matter how you program your AI, whatever it's trying to maximize, the types of AIs that are going to let you live and not recycle your atoms for computation is vanishingly small. The majority of AIs that you can create are going to want the most possible energy and matter to do what they're trying to do. And so, of course, they're going to recycle the atoms that make up your body, okay? And his objection to that is that not all AIs need to be utility maximizers. So in that convergence of AI drives paper, it was assumed, or at least the way I read it, is that we're assuming, certainly that's what it pertains to. It pertains to utility maximizers. Things that say my ultimate goal in life is this, and whatever I need to do to optimize that, I'm going to do. They're basically like a religious fanatic optimizing for one thing, right? I found the actual sentence so that I can be even more precise on how I'm stating this. The instrumental convergence thesis is what it is. Omohundro 2008, Bostrom 2012. So yeah, by those two guys, the instrumental convergence thesis says that for most choices of a utility function, instrumentally rational agencies will predictably wish to obtain certain generic resources such as matter and energy, and pursue certain generic strategies such as not making code changes which alter their effective future preferences. Okay? So that means they're going to want all the energy, all the matter, and they're going to resist to having their preferences changed, which means that the moment it knows that you want to go there and push a button to make it want something else than it already wants, you're gone. And then he provides some alternative vision on this, which is that this convergence really only talks about motivation systems for AIs that are simple utility maximizers. And he makes this extremely bright observation. If I'm an AI and I'm not a utility maximizer to begin with, meaning that my level of pleasure with what's going on and with my level of activity in the world is not straight just to optimize one super goal, then I have two choices. I can either become a utility maximizer, which is going to allow me to get the things that I want better. So from that standpoint, I should want to be a utility maximizer. But then if it's able to also have an intuition for the fact that there might be things that are valuable, but which it doesn't know are valuable yet, then it would find the proposition of becoming a utility maximizer very, very dangerous, to the point that it would not want to become a utility maximizer. If it's able to know that there are things that I should want, but I don't know what they are yet, then it will never become a utility maximizer, because that automatically closes the window of possibility of pursuing, wanting, and achieving the things that it doesn't know yet that it should want. Okay? Extremely subtle point. This is what intelligence is. Okay? Not being bitchy, having hit the wall, being cougars, and saying that men don't want you because you're too intelligent. Arthur out.